Hi guys, this is lesson 7.2.1, review preview, problems 56 through 62. So let's start off here. Remember we were using the sum of all angles equals 180 degrees, our Pythagorean theorem. And reviewing some of our trig functions. That's what we did in class today. So that should be the first two problems here. So 756 says, what's wrong with this diagram? After drawing some diagrams on his paper, Stefan thinks there's something wrong with his diagram labels. Examine each diagram below and decide whether or not this triangle could exist. If it cannot exist, explain why. So let's just use one of those things we know about triangles. I know that I have to add them all the angles equals my sum of all my angles equals 180. So let's just double check that to see if it works. So we have 108 plus 40 plus 22 equals 180. 40 plus 22 is 62. 108 plus 62 is 170. 170 does not equal 180. So that means this first one is not a real triangle. Okay? Does not exist. Let's go ahead and look at B. Ooh, right triangle. Okay? I know my right triangles, I can use my trig function, sine, cosine, tangent. We can also use the Pythagorean theorem. So we can double check this. Does a squared plus b squared equal c squared? Remember, our c always has to be across from the 90-degree angle. Okay, that's the largest side. So that would be 12 squared over here. And then our a and b, it doesn't matter which one we choose. So we're going to go 7 squared plus 12 squared. Nobody ever texts me. 7 squared is 49. 12 squared is 144. 12 squared is 144. Already looking at that, you guys. 49 plus 144 is going to be greater than 144. They're not equal. This triangle also does not exist. Okay, let's go on to 757, multiple choice. Yay. Based on the relationship provided in the diagram, so we're looking at this cool triangle right here. Which of the equations below is correct? Because we got some geometry symbols in here that we have to remember if we've forgotten them. If I have an angle, I put this little half circle around it. Okay, I draw a little line, that means angle. If I draw a dash, that dash means they're equivalent or they're the same. Okay, so it's telling me that this angle and this angle are the same. Not this one. That's the one I used for an example. So if they're the same, we can set those two equations are equal to each other. So that first angle is 9x minus 3 equals 4x plus 2. Let's go ahead and see if any of those match up. No. 9x minus 3 equals 4x plus 2. I believe it's B. Hit the cool extend the page button. Look at that. Okay, 58, cruising right along. So this is the stuff we did last 7.1 to 7.4, okay? We're condensing or expanding our logs. Compute the value of each expression without using a calculator. Okay, we have, for A, we have the log of 8 plus the log of 125. I have, both of these are base 10, and there's a plus sign in the middle. So our formula says we keep the same base, we can multiply these together. So it's 8 times 125. Fancy pantsy without a calculator here. 825 times 8, 0, 4, 16, 20, 8, 1,000. So we have log of 1,000. I still don't know what that is, right? Like, why can't I type that in, Miss H? Okay, we can change this to an exponential. 10. We're going to make up a letter on the other side of that equal sign. 10 to the x equals 1,000. 10 squared is 100. 10 to the third, because I have 3 zeros, is 1,000. So my x equals 3. Essentially, you could have typed this into your calculator. You would have gotten 3. For B, we have log base 25 of 125. If I change that to an exponential, I have 25 to the x equals 125. My x, I would change these both into base 5. So 5 squared x equals 5 to the third. 2x equals 3. I solve for x. I have x equals 1.5. Just a reminder for us, I did teach you guys all how to use your calculator here. Whoa. That is not, where is my calculator? There we go. Okay, so before you get onto our Desmos calculator and we go the log, shift minus to get that little thing below, 125, we get 1.5. If you ever want to change that to a fraction, hit the fraction button, you get 3 halves. Let's move on to C. So we have 1/2 log of 25 plus log 20. So we have a multiply out front, so I have to put that as my exponent. I have to do that first before I can combine those. So we have log of 25 to the 1/2 plus log of 20. We have the same base of 10 and a plus sign in the middle, so we can multiply those together. Log of 25 to the 1/2. Ooh, times 20. Since I'm not using a calculator, 25 to the 1/2 is the same thing as saying the square root of 25 times 20. So I have the log of square root of 25 is 5 times 20. Log of 5 times 20 is 100. If I change this to a exponent, I have 10 to the x equals 100. Okay, I'm just making up a letter on that side. So I have to think of 10 to what number? So 10 squared. So my answer is 2. For D, we have 7 to the log base 7 of 12. We can rewrite this. Okay, 7 to a number equals the log of base 7, 12. Okay, I can also rewrite this side. That says 7. Oh, shoot. Don't think I'm doing that right. 7 to the x. I'm pretty sure I didn't teach you guys. I think I did. This was one of our little theorems from the other page, where it's 7 log 7 of 12. Since I have a base here, and I'm raising it to the power of the same base, these two things cancel out. And my answer is 12. I'm just going to show you guys how to type that in. These are one of those weird ones that 7 to the log base 7 of 12. Okay, we can also do that the other way around. Okay, if I have log base 7 to the 12, I think I showed you guys that before. So if you have a log with the same base, and you have the same base there to the 12, these two things cancel out. Okay, so if you have the same base and you raise it to the log, or you have the log and you raise it to that base, they can cancel each other out. Extend the page. 759, we have graph the inequality. We got x squared plus y squared is less than equal to 25. Okay, I know x squared plus y squared is a circle. If I change this to a circle equation, that would be 5 squared, right? So this 5 is my radius. So I can graph this, x squared plus y squared. There's no h and there's no k. So that means 0, 0 is the center of my circle. And I'm going to go out 5 places. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to be super cool here and draw a very perfect circle. Oh wait, is there a circle tool? See if I can be real cool. Oop. Oop. Give me a circle. That was cool. My radius is off though. Cool circle tools. Okay. This says everything inside. Okay, my x and y must be less than the line, less than the radius. So I'm going to just shade in everything on the inside of that. I believe we skipped 60. Where do we go down? Yep, 60 is a stats question. We skipped 60. 761. For each function, determine the x and y intercepts and the locator point, HK. If you haven't already done so, write your equations in graphing form. Okay, A, we have y equals 7 plus 2x squared plus 4x minus 5. Remember, we have to reorder these and combine all of our like terms. So y equals 2x squared plus 4x minus 2. I take a look at this thing, I'm like, ooh, they can all be divisible by 2. I can pull that out. So you get x squared plus 2x minus 1. Let's go ahead and factor that on the inside there. I draw my diamond. What multiplies to get to negative 1, adds to get to 2, multiplies to get to negative 1. Pretty sure our only choices are negative and a negative, or negative and, wait, can we do this one? 2, 2, 2, 2. 4, I screwed that up. That's a positive 2. Nice little mistake there, Miss H. So we get to go ahead and go back and erase those. What multiplies to get to positive 1, adds to get to positive 2. So my multiples of 1 are 1 times 1. Add those together. Oh, I don't like how big that line is. Shrink the line. So I got x plus 1 times x plus 1. Break those apart. My x equals negative 1 twice. Okay, so I can put that back, I can put my negative 1 back into my equation. So we got y, ooh, watch this, I gotta extend the page. I don't have to put it up there. Okay. We got y equals, it doesn't matter which equation I plug that back into. So I might plug it back into my easier one there. 2 times negative 1 squared plus 4 times negative 1 plus 2. Negative 1 squared is a positive 1. So this is 2 minus 4 plus 2. We get y equals 0. So my equation for this one is y equals 2x minus plus 1. I'm freaking out. 761 plus 1 squared. Because our h is -1 and our k is 0. I'm going to show you guys on B the easy way. Okay, for B we got, it's a much bigger equation, right? Let's try to use Desmos to figure this one out. So we have a quadratic again. We got x squared equals 2x plus x, 2x minus 4 plus y. I'm going to type that in. I'm going to switch my x and y here first. You know, guess what? We don't even need to. We can take that whole equation and plug it into Desmos. We got x squared equals 2x plus x times 2x minus 4 plus y. I'm going to double check I wrote everything in right. Cool, same equation. We'll take a look here. What's my vertex? My vertex is 1, 1. So I'm going to take that vertex of 1, 1 and I'm going to make a graphing equation with it. My graphing form for a parabola I ran out of extend page. Used too much page. Okay, my graphing form for a parabola is y equals a x minus h squared plus k. So my hk in this case is, my h is 1, my k was 1. My only question is if I go over 1, that's 2. If I go over 1, down 1, over 1, down 1, my a is also 1. So I got y equals x minus 1 squared plus 1. My thing was facing down, so my a is negative. I can go ahead and double check that. Make sure I wrote in the right thing. If I want that graphing, that green line to match the one I just wrote. Y equals negative x minus 1 squared plus 1. My purple line and my green line are the same. Okay, I can turn my purple one off. Same spot. 672. Okay. This one's a little long. Okay, bear with me. It says the Portland Zoo is building a new children's petting zoo that will contain 6 goats. One of the designs being considered is shown to the right in the shaded portion. So our goal here is to figure out the area of the shaded portion. So I'm going to start and I'm going to figure out the area of that little white piece on the side there. It looks like it's a circle. Those lines mean there that those are the same, so that's a radius of 4. My area for a circle is 1/2 pi r squared. Since we only want 1/4 of this, we're going to divide that whole thing by 4. Our radius, our r equals 4. So we got 1/2 pi 4 squared divided by 4. And I'm going to just type all that in, okay, just like it says, 1/2 times pi, hopefully we have a little pi button, times 4 squared, and this whole thing divided by 4. So the area, that little white piece up there is, oh, just disappeared on me, 6.3. Sweet, got the little white piece. Now let's break this up into another piece that we could possibly figure out. That's a square. We got 10 on top. This whole thing's a rectangle. We know that because this is a right angle and this is a right angle. So this is a right angle and that's a right angle. So we have a rectangle. So the area of a rectangle is base times height, which is 10 times, so 6 plus 4 is 10. This side, we know these little dashes are the same. So that's 4 and 4. So that side is 8. 10 times 8 is 80. So this whole piece is 80. It's a 0. And this is 6.3. Now we got to figure out this triangle piece. So we got area equals 1/2 base times height. My height is 8. And my base is, I have no idea. Okay, we need to use some trig here. We have an angle here and we have an opposite. Well, what else do we know? We have an angle and an opposite, and we're looking for adjacent. So I'm going to use tangent. Get the tangent of 78 equals 8 over x. Multiply both sides by x. Divide by tan of 78. I get x equals 8 divided by tan of 78. I'll take out my handy dandy calculator here. We have 8 divided by tan of 78. 1.7. Oh, was that 1.7? Did I round correctly? Yep. Okay. So if I look up here, I got this is 1.7. Sweet, so I can find the area of that pen. My base is 1.7. My height was 8. So my area of that little piece is 6.8. So this is 6.8. Okay, we can add all three of those up. 6.3. So my area of that whole shaded region is 6.8 plus 80. And then we're going to subtract that quarter triangle, so minus 6.3. The feeling that I'm off. 1/2 base times height. Today, Sierra Robinson, and wants to travel all the way to Rhode Island from Utah to join us here at the University of Rhode Island. So I will let our panel of interviewers go around and introduce themselves to you, and then we'll start the interview. I see Mr. 1/2 pi r squared divided by 4. Okay. Plus 6.8. Yeah, that's not right. I feel like I typed this one in wrong. 1/2 pi r squared.
Hi, Ms. Robinson. I'm Ms. Malloy. I am first year at Ames. I am not
Divided by
teacher
4.
here at Ames. I have been teaching just 1 year previous, but have worked in education for about 18 years. So it's good to have you here.
Sienna, you know me and I'm your worst nightmare.
Oh, I know what I did. It's not 1/2. I combined 2 formulas there. That stinks. I'm sorry, guys. My formula is off. It is not 1/2. It's pi r squared divided by 4. So if I multiply this by 2, it's 12.6. Sorry about that. So we have 6.8 plus 80 minus 12.6. We get 74.23. B says how many meters of fence are enclosed in the petting zoo. So we're missing one other piece for the perimeter. We're missing this side right here. So we need to use the Pythagorean theorem to find that one. So this is B. So we have 8 squared plus 1.7 squared equals C squared. So I have 8 squared plus 1.7 squared equals 66.89. So C equals the square root of that. What? Square root of the answer, we get 8.17. We have to go ahead and add all those sides up, and I'm going to try not to screw this up this time. Let's check first, did I round right? 8.18. Shoot. So we have 8.18. That top part is 6. This side part is 4 plus 1.7. I think we're missing this piece right here. Okay, to find the circumference, we go 2 pi r. My r is still 4. So we get 8 pi. And it's only a quarter, so we have to divide that by 4. So that's 2 pi. So we're going to add 2 pi. So 8.18 plus 6 plus 4 on the side, plus 1.7
What are some of the challenges
plus
that
2
you've experienced
pi.
in your own limitations that you've found ways to overcome?
10 plus 8 plus 8.
One specific example I can think of is I'm a figure skater also. So in figure skating there are these things called skating tests, and so we do different
4.
skills from the judge, and they kind of just decide whether you pass or not.
I got a 4. Got the 6 on the top. Got the 2 pi. Got the 1.7. I got the 8.8. I am missing the 10 on the bottom. 36.16.
One of the comments that I got a lot that I was able to work on was that I was a good skater, but I lacked confidence sometimes. So getting
And our last one, animal rights activists call for each goat to have at least 1.1 square meters to frolic. Will this pen be enough? We have 6 goats. So we're going to take our area, 36.6, divide by 6, which is 6 point something close. So that would be a yes for C. All right, thank you. Have a good day.